Alice, we can start.
Okay, sir. Good morning to one and all gathered here. Myself A. Alice Lindsay, Faculty, Department of ECE SRM IST Rapamram Campus, along with other coordinators Dr. Ushas ma'am and Mrs. K. Lalita ma'am. Welcome you all for this webinar. We sincerely express our thanks to our management for giving us this opportunity to conduct this type of webinars for the beneficial of the students from various domains of ECE like EKE, Biomedical Engineering and ECE. We extend our thanks to our HOD sir and all other faculty members, VP Academic sir, VP Academic, VP Admin sir and Dean, Director sir of our campus for encouraging us to conduct these type of events. I welcome our guest for today's session, Ms. Richa ma'am, for accepting our request and attending this webinar. I welcome all the participants. Welcome you all.
Am I good to go ahead?
Yes, ma'am.
Yeah.
So about our speaker for today's session, Ms. Richa Matthew Abraham completed her BE in Biomedical Engineering from Rajiv Gandhi College of Engineering in the year 2014. After that, she worked as project associate with Polymer Engineering and Colloidal Science Lab from IIT Madras. She has 6+ years of experience in this biomedical field. Currently, she is associated with Zippo R&D Solutions, and Madam is working as a business system analyst of the technical consulting team with Zippo. We welcome you, ma'am. The session is over to you now.
Thank you, ma'am. Thanks for the welcome. Just a slight correction. I'm not a business system analyst yet. Though I work for the business analysis, I'm still a senior scientific application analyst. So yeah, it's fine. But anyways, it's a pleasure meeting you all this morning. I'm really glad when Nushis ma'am was reaching out to me. It was indeed a pleasure, to revisit the days when we were studying engineering in college and able to speak to ma'am again and getting this opportunity. It was really great. So I request students, if you could just switch on your videos. I know last week there was a similar request as well, but then uh, I don't think many of you had switched on your videos. It'd be really good. I don't mind how you guys look this morning, but it'd be nice if you can just switch on your videos and, uh, so that I can just have this feeling that I'm not speaking to a blank screen. I'll just wait for a couple of minutes for you guys to do something, switch on your video. Till then, yes.
Yes, participants, please turn on your video. Participants, kindly turn on your video.
Right, then I guess I will share my screen. So I do see a lot of videos turned on. Students, can any of you share the screen? Because the session is for you. So if I'm not addressing you guys, it seems a little different. So. Right. I guess I got a few videos. Thank you. So I'll just start sharing my screen. Let me know once you see it. Yeah. Are you guys able to see it?
Yes, ma'am.
Yeah, yes, ma'am, it's visible.
All right. Okay. So again, I thank you all for setting aside time and joining this webinar. So my topic for today is about the coexistence of research and informatics science, and I will also be talking about opportunities and R&D for biomedical engineering. So I think few of you here are biomedical engineering students. Some might be from ECE, but all the more, it's actually nice to look into certain fields where you can explore, where exploration is the main theme, and you can go ahead and search for what is the future for me in it. So last week, if you had attended the webinar, I think Janardhan, who is my classmate, would have given you some idea about what you can do in the future. How I remember this point that he was talking last week about how you will always be at war with doctors, and how you can, there will always be a difference of opinion and things like that. So I think he gave a much bigger, an idea of how biomedical engineers work in a hospital environment. But today we'll see something different, but something that's very essential of how things function, especially in a world that is in post-pandemic. I think when we were students in 2014, not very long ago, we just give me 1 minute. I think, yeah, just give me 1 minute. I will be back. I'm so sorry. 1 minute. Sorry for the interruption. I had to, I just figured out that I didn't plug in my laptop. So, yeah. Right. So, yeah, as I was telling, when we were students in 2014, we didn't know what a world was with pandemic, or how would a world be post pandemic. But then right now, the reality is that we are staring at this reality where a pandemic has struck us and has literally changed the way how we function. So if I had an option to sit at home and study, I think I would have cherished it, because the travel that I had to take up every day to college and getting back was exhausting in itself. But I think that is one plus that you get out of studying from home. But then again, the environment of mingling with people, with your professors, going to the library in college, going to an auditorium and looking at your college fest is difficult, I know. But we are staring at a world like this, so it'll be better to change our perspective of how things would be in the future. So, in order to make that future real, future is something that we can all say that I don't know what my future holds for me. I don't know what is there in the future. I will leave it all to destiny. It's very easy to say. But then, as engineers, we are the ones who model the future for everybody else around us, not just us. It's research. So research is something that bridges your past and your future with what you know in the present. So I think it's very important to focus on research, and I thought, okay, let's explore something in this part of engineering where I have a little bit of experience. I know that there are many of your faculty who are doing active research, many of your faculty would have finished their PhDs. I'm not as experienced as them, but then because I see things in a day-to-day basis, I thought I will just share that with you. So yes, so this is more about the introduction. So yeah, next is just a small intro about me. So I'm, as you guys know, I'm Rika Matthew Abraham. I go by this norm where I'm a scientific informatics professional. So it's a bit of both worlds, research and informatics, which we will discuss more in detail in the few forthcoming slides. So yeah, I did my biomedical engineering in Rajiv Gandhi College of Engineering from 2010 to 14. I passed out and I went in as a research associate at IIT Madras. I was there for a year. And then I took a 6 month break. I was wanted to decide what I want to do. And then I started out as a scientific analyst in CIFO R&D Solutions. And then, yeah, so it's been a journey that's continuing from then. But I think it's been a very rewarding journey. So, yeah. So, next thing, I think even before jumping into what research is and all, I would like to give you guys a story, something that I came across. I think a couple of days back, I was, you have these random YouTube videos that pop up when you are listening to something else that say, okay, that piques your interest and say, let me just go and check what this is. So this is one such random YouTube video that made me think, and I thought I will share it with you guys before I go into um, the topic today. So the chemical structure that you see over here is something called thalidomide. Thalidomide was a drug that was hailed as the next big thing. When? I think it was around 1957. So, when we're talking about something historic, it's always good to imagine. So, all of you are aware of the World War II. Can you please give me reactions? Right. I see a few reactions. Yeah. All right. So we all here heard about World War II, right? So that was like kind of like the biggest pandemic. Like now we have COVID. So then it was World War One, and then immediately there was World War II. So people in that area during that period of time, especially countries that lost the war, like Germany and Italy. So people had a continuous trouble in getting their sleep aligned. People were sleep deprived. There was a lot of stress. There was depression. There was anxiety. The terms that we call now, people don't know it much. They were just like we were sleepless. So they were sleepless for many days together, many months together. That's when a particular compound was identified. It was called thalidomide, and they did a lot of research. Yes, and they tried it on rats, and it was like the biggest invention that people came across in terms of sleeping tablets. So this what this invention did was that it didn't kill any rats. So let's say we have a control group. So when we're doing research, what we do is like we inject rats. So that's how you do your clinical trial with rats first. So those times it was on rats, and they were injecting rats with like lethal doses of the drug that would kill any amount of rat in any other drug that they took. But then this drug was so magical that it didn't kill any rats. Even the highest to the highest doses, the rats were running freely in the lab and inside the cages. They had nothing to worry about. They were just, non destructible. The rats were alive. And people thought, wow, what a drug is it? It cannot have any lethal capabilities to kill any rats. So what can I do is I'll market it in the for the public, and maybe because it has this sleep inducing capabilities, I will introduce it to people and we can take it forward. It's going to be the next magic drug. So there are, drug classifications. It might be all new terms. You might think, what is this? She's talking about something that I can't even relate to. But yeah, just hang on with me for a few minutes. So there are drugs that are classified as barbiturates and narcotics and things like that. So if you take any sleeping drug today, it will be under classification of narcotics that is used only for medicine, be it morphine. You guys would be familiar with morphine. If you'd known how Michael Jackson died, it was because of an overdose of morphine. So those were some classification of drugs that were like they are narcotics, they are legal, they can be abused, they're all called drug abuse drugs. But then these were something of not at all of that classification. This was something different. So they were like, okay, let me use this in the market. So there was this chemical company called Grunenthal in West Germany. West Germany, East Germany thing was happening here. There was the Cold War, and West Germany was aligned with the West, as in the US and things like that. So they came up with this drug, and it was done by this company called Grunenthal, and it was found to alleviate stress, and people are able to sleep magically and peacefully. And then there was one doctor in Australia who thought, let me just try this on a few of my patients who are pregnant because they have morning sickness. So, uh, morning sickness is this period in the first trimester and pregnancy where people go through the worst of the worst, where they keep vomiting, they are tired, they have fatigue, they're anxious, and things like that. So, that's morning sickness for you. So, this doctor thought this drug is good. So, why not just use it for my patients who have morning sickness? So, he used it and he found brilliant, you know, they got a very good effect, after effect of the drug. Morning sickness was alleviated. And things were fine. Grunenthal was so happy because they were going to produce millions and millions of doses of this drug. And they thought, let me introduce to the entire European market. That's when this was happening. And unfortunately, what happened was people gave the drug, they knew morning sickness was alleviated, but there weren't enough studies to see what happened to the babies that were born after this drug went inside them. So, the fetus is growing inside the mother's womb. The mother is taking the drug, but no one thought about this channel of how this drug will travel through the placenta into the baby. I don't know if you guys are into the second year, you would be learning anatomy and physiology in biomedical engineering. But then we've all come through biology backgrounds, I'm sure, till at least till 10th standard we would have studied biology. So we know what a placenta is, we know how the fetus is developed inside the womb. So, see, any drug that the mother takes travels through the placenta into the fetus. So, doctors or the drug companies, especially Grunenthal, never did any such study of what will happen to my patient once the baby is born. That was something that they overlooked. Then it so happened that babies who were born after that the mother took an administration of thalidomide were born like this. They had limbs which were called as phocomelia, which is shortened, absent, or flipper like limbs. So it's not just the hand that you see of this child, but then it's also about the legs. So if you had known about this speaker called, there's this motivational speaker who goes by his name Nick Music. Uh, just search about him in YouTube or Instagram or anything. You would find that there is this one person walking around in a t-shirt, but he doesn't have two arms nor two legs. It looked like as if it's only the torso that's moving. So something very similar to that's called phocomelia, where children born after every administration of this drug, almost all the children that were born like this. Very sadly, the company never took any reliability or acceptance of, yes, this is my drug that made the children like this. They were completely in denial. They told, my drug will not cause this because it didn't make any changes on the rats. That's when this drug was it's like your Dolo 650. Anybody everywhere in the world will know about Dolo. It was going in that kind of a popularity where it doesn't cause any because it was only affecting the mothers who were pregnant. It was not about the child. It was not about in any other normal human being. They didn't have any side effects. They were completely fine. They thought, okay, it's fine if some children are born like this. It is not because of my drugs, but because of their genetic condition. So that was the company's perspective on it. But then there was this one lady in the US. She was working with the FDA. She was a pharmacologist, and she was taking care of the approvals of drugs coming inside FDA. So if you don't know about FDA, FDA is the Food and Drug Administration that gives a stamp on every drug that comes in or is made or is a research is done on the drug. It has to pass through every approval to go into the market. So we have, these are called as regulatory bodies. So US has FDA, and there are similar institutions in the European Union as well as in India. It has to pass through the Indian Medical Association and ICMRI. So there are a lot of regulatory bodies that it would be nice if you guys know about it. So FDA was fine with it because they wanted papers. So every time a drug is produced, they need a paper that says a study has been done, a group has been gone through trials, and we are fine with the results. So that is the paper that FDA needed, and Grunenthal was able to give this paper. But then um, this woman, this lady who was this pharmacologist in FDA, she told something is not right. I think there is a connection between this, because she found out that how this clinical trial was happening is that clinical trials were done in patients, but then the patients were never brought back and studied of the after effects. And she told, I will say that this is the drug that is causing so much of disturbance and we will have to ban it. It was around 1960s, I think around 1961, when John F. Kennedy was the president of the United States. He told, if this woman is saying something about this, then I think there is some truth in this. And she was able to prove the FDA papers wrong, because they found that there was one person whose address even wasn't able to be traced. And some clinical trial that they have pronounced, and it's not right. She was able to prove it, and around 10,000 children are affected, and still the survivors are there. There are a lot of people that you would see. Just log into YouTube and search for Thalidomide tragedy. You would find a lot of documentaries about this. So you will find that people are still alive. They're 50 years old, 60 years old, who say how their life has been affected by this drug. Yes, these people are still alive. And in 1961, so this is the heroine of FDA, as how they told in the newspapers. She was called Frances Kelsey, and she was a pharmacologist who told toxicity testing has to be brought into every drug that is coming into the FDA. So I think you guys know about toxicity, right? Can someone tell me what toxicity means? I don't want you guys to explain about toxicity testing, but can you guys say about what toxicity is to you? Can you say about it? Someone? Can someone unmute and tell me what toxicity is? I will wait for your answer, because at least then let me listen.
Poisonous thing, like the presence of how much poison present in that particular drug, which affects human body.
Yes, that is right. So toxicity is about how toxic this drug can be. Can it kill? Or as how Mr. Ajay Daniel told, absolutely right. Can this drug affect me and kill me? So that is very simply put in terms of toxicity. So is rat poison toxic? Yes, it is toxic. How do we know it? It's because we know that it has gone through some tests, and there are some components or some compounds inside this rat poison that would kill us. It kills rats, so can it kill us? Yes, it can. So that is called toxicity. And toxicity testing. So every drug that passes through FDA has to submit research trials and research papers that says, I have done a toxicity testing to my drug, and I know that this much quantity. Okay, so as I told about these narcotic drugs, right? So if you see morphine, if morphine is given in one particular amount, let's say zero point 0.5 micrograms, then it will induce sleep in me. If I'm going to give 50 grams of morphine to you, you will die immediately in 5 minutes. That is toxicity. How much substance should I give for it to be a drug and not to be abused as a drug? So that line, where do you draw that line? That comes in through toxicity. Okay, so she was the person who made sure that every drug goes through this toxicity testing. So it was Frances Kelsey who did this. So I think in 1962, around that time, when she fought and fought and fought, and finally it took a long legal battle for the Grunenthal to stop manufacturing it completely. So that is the history of thalidomide. But you know what happened? Around 1990s, there was this one researcher who thought he was searching for drugs to alleviate pain in leprosy. So you know what leprosy is, right? So we would have seen a lot of people with leprosy. You've heard about Mother Teresa and people who fought to completely eradicate leprosy from the country. So leprosy is this very gruesome disease where every one of your nerve joints is affected and you wouldn't feel pain, and you would see that your arms and your limbs are slowly being eaten away. So it's a very gruesome disease. But then there's one doctor who was searching for um, drugs for leprosy. And that's when this doctor found, okay, Can I do something with thalidomide? He knew that there was something in thalidomide that was helpful. So he was an Israeli doctor. I don't remember his name, but he was an Israeli doctor who thought, even though it was banned, he had some doses of the drug with him, and he gave it to a patient who was almost in stages of dying, and he found very brilliant effects of this, but it was way back in 1968, and the drug was almost stopped and he couldn't do much about it. Around 1990s, there was another researcher who thought, okay, I knew that there is one study published about this. Can I uh, search for any other better alternatives? And he found that thalidomide can be used in treatments. So, research led to its use in leprosy treatment and then also multiple myeloma. So, multiple myeloma is a type of cancer that again affects your nerves and it forms a lot of tumors everywhere in the body. And thalidomide had this brilliant technique where it could just stop the tumor as such. So it was a chemotherapeutic drug that came out of it in the end of 1990s, and in 2000, FDA once again approved this drug to be used in very controlled quantities. For very very controlled quantities, and they could be used as chemotherapeutic drugs even now, you would see. But then again, there had to be a lot of warnings that even now, if you see the thalidomide drug, it comes as a capsule. You would see that there is a picture of a mother and a fetus and it says banned. So every drug had to be put up like that. So any leprosy patient who is pregnant, or in case of this very gruesome condition where a pregnant woman has cancer, they cannot take thalidomide. But then still at some places like Brazil, you would still find in the poor slums of Brazil, some people use this drug when they're pregnant because they do not have access to healthcare, and children with phocomelia are still born, but then it's highly, highly controlled. And now clinical trials are being going on for its use in Crohn's disease, in TB, in AIDS, and also in rheumatoid arthritis, but it's all in very um, what do I say, in a very nascent stage of research. So there is still a lot going on. So, what made this tragedy become a treatment? Can any of you tell me what led? Thalidomide was a drug that was kept as a tragedy and was banned for 30 years. It was not in production, or let's say people had a negative perspective about thalidomide. But what made it get back into this class of treatment again? Can anyone tell me? I think I will start picking out names. Ananya, can you tell me what do you think about what made this tragedy become a treatment? Ananya, 173 Ananya. Can you unmute? Just there is no right or wrong answer. You can just
Yes, ma'am.
Yeah. Can you tell me what has made this tragedy become a treatment?
I really don't have idea.
The answer is right on screen. Fine, it's fine. It's all right. Thank you for unmuting. So, see, it was the research that led into use for leprosy treatment. So, a tragedy to become a treatment, you need research for it in between. So, unless and otherwise, there was this one doctor or this one researcher who wanted to say, okay, let me try treating my patients. Yes, it was a banned substance, but then they would have got the right permission from the patient as well. So things would have been done in the right way. And they got to know that after years of research, that this drug, which was classified as lethal, can be made into a treatment. So that is where research plays a role. And as biomedical engineers, you would think someone put me into biomedical engineering, because I remember I went through the same phase when I went into class for the very first day or second day. I had my entire group of classmates who told we got into BDS, But then my dad told there is an every other dentist in every street. You will find 3 or 4 dentists. So he told, I'm not wasting my money with BDS on you, so I'll put you into biomedical engineering. And that is how I ended up in biomedical engineering. There were just 3 or 4 people of us who were into biomedical engineering because we wanted to get to biomedical engineering. And there were a few more people who thought, biomedical engineering, I don't even have to look into circuits or anything. It's straight anatomy, physiology. I'll write my exams, I'll become a biomedical engineer. Unfortunately, that is not how biomedical engineering works. You need a little bit of electronics, you need a little bit of mechanics, you need a little bit of civil engineering, which is very surprising, but you will still learn it in your first year. And you will need anything and everything in your engineering departments to constitute into biomedical engineering. Okay, so anatomy physiology படிக்கிறதே பெருசு, or studying anatomy and physiology, you will feel like I'm on par with doctors because I can talk about anything that they know. That is what you guys will think. But then, yeah, doctors still have to, fight it out for 6 to 7 years of their life, another 3 years in MD, and then they will be called doctors. And that is why they have that, that pride that I'm a doctor. It is very, I would say that it is very logical for them to have that pride. But you also study anatomy and physiology, but you also study electronics, computer science, Java programming, neural networks, and all these subjects in your college. So I think it's better for you guys also to be a little bit proud and say, I am a biomedical engineer, because I have seen when I did my engineering, when people say, oh, I'm just a biomedical engineer, they'll be so sad. They'll be very, very sad that they took biomedical engineering. They will think, even after finishing college, they'll say, எனக்கு scope இல்லை, or I don't have any scope in this. I don't know what to do. Please don't be like that, because this is the in thing now in a post-pandemic world, like how I spoke about in the introduction. You need biomedical engineers. Your ventilator machines, that is so highly talked about today. The second wave struck, and we were saying there were no ventilators. We don't have biomedical engineers to service ventilators. So when you go into hospital training, I hope for biomedical engineering students, especially if you go into hospital training, I think around your 7th semester or your 6th semester, you would be mandated to go into hospital training. That's when you will see that every ventilator that goes into a patient will have to come back to the biomedical engineering department in that hospital, have to be cleaned, have to be serviced, and then given for the next patient. But now, very, very gruesome in the second wave that we saw, that people are suffering from black fungus, which I don't think there were any statements or any news to support my theory. But what I thought, or what at least as friends we were discussing, is that definitely that ventilator would have been used for multiple patients, because saving a patient is more important than servicing that machine and putting it for another patient, because we have so many beds filled with people are dying, they have to be saved. So this, very sadly, I don't think these ventilators were serviced. And when you pass on one oxygen mask to another and have all these virus and the fungus and the microbes and everything inside your ventilator tubes, I think when you study about ventilators, I believe you still use this book called R.S. Kanpur. Any professors, do you still use Kanpur, the book of instrumentation in biomedical engineering? Is that book still around? Lalita ma'am, or Alice ma'am, someone in the biomedical. Yeah.
Ma'am, actually, we are from ECE
Okay.
department.
All right. Okay.
We can
No
just
problem.
started in this year.
All right.
Students
All
are
right.
actually
Okay.
only in first year.
All right. Okay.
Okay, ma'am.
Okay. Yeah. So yes, I think there is this book called Kanpur. Even if it's not in your curriculum, just make sure you borrow it from someone of your seniors. Try opening that book and just look at what are the instruments that are there. They will explain to you guys, okay? Or you have YouTube, guys. We didn't have, when we had YouTube, you know what happened? We had to wait for 1 hour for a video of 5 minutes to load. And even way back in 2014, we had internet, we had our dongle and stuff, but for that one video of 5 minutes to play, we had to wait for so long. But now you're in the age of 4G and 5G, and please use YouTube for something as useful as this. I think hopefully if you have any If you're curious, you can go and look at how ventilators are structured. So yes, I was talking about how ventilators were not serviced, and it might have led to black fungus. You never know. So that is how important biomedical engineering is to this world. But we are slowly neglected. I wouldn't say it's because the world is a messed up place and that's why biomedical engineering is neglected. No, we are yet to find the value of biomedical engineers, because I came from a house where my mother was working in Apollo Hospital. She was the ICU in charge over there, and she knew about a lot of machines. And she used to tell me when I was young, she was like, we had service engineers coming in from Germany to service the CT scan machines and the MRI machines. And I was thinking, wow, that's brilliant. And she told, what, they're not any of the engineers that they know. They're classified as a specific biomedical engineering category. And for a machine to be serviced, they had to be flown in from Germany to come to India and do that. But now we have biomedical engineers. I think there's biomedical engineering department in every college now. So you don't have to fly in from Germany anymore, but you can fly out to Germany. That I will guarantee. Someday it will happen if you still stick on to the biomedical engineering field. So that will happen. So yes, that is how I got into biomedical engineering. I had a sound knowledge of what biomedical engineering brings, but unfortunately, I think we are all little, we think about, okay, I hear about biomedical engineering somewhere in the news clip. I would have seen there is something about biomedical engineering. That's how I came into this. Do not be disheartened because you didn't get your medical seats and you had to take up engineering and be a biomedical engineer, because I would guarantee that this is one field that is growing. This is one field where you will still have opportunities if you look into the opportunities. We are into this phase where even our jobs are given to us through placements. Yes, that is good. That helps us to not be uncertain of our future. But guys, the true worth of your engineering degree will come in when you go door to door for every company and search for a job. I had done that. I mean, we had placement, but I didn't take it up. I wanted to do something else differently. And then after that, I had to apply for a lot of companies and sit in for interviews. And very fortunately, for my second or third interview, I got into this company that I'm working in right now. But there might be some of you who would think, I know a certain person who has done biomedical engineering, and I think they're still struggling for their job. But that might be the category if you don't look properly. If you're right now in your first year, this is the best time to start. Enjoy your college life, because this is one place where you won't get time to explore your future any better. I cannot be in my fourth year and say, okay, now I want to explore what I want to do in the future. I would think that it's a tad too late. Yes, you still can. You can take a 6-month break, like how I did. So after my research in IIT, yes, you can. If you have the capability to sit and wait, yes, you can. But at least when you're finishing your second year, when you go into your third year, start looking into opportunities that you might get when you step out. Can I do this? Can I do that? We all have this tendency where we think about a final year project only in the final semester of fourth year. But why not be different and think, okay, let me think about what I want to do in my final year project, probably at the end of the third year, at the beginning of fourth year. Let me structure my mind how I want to do my final year project. That is one thing that you guys can do. Does it classify it as research? Yes, it does. Because you're thinking about what you want to do in the future. So anything that you want to build up in the future goes through this process of research. And that, my guys, is research. And now let's come into what research in biomedical engineering is. Okay. Um, so just to give you a context, so you see a petri dish, you see a pipette, you see this person over here. They're working something with blood. Uh, does it classify as biomedical engineering research? A few people might think, oh, this looks like some biochemistry lab, some biochemist is doing something. Or maybe biotechnology engineers would do something like this because, sorry, we work only with machines. No, that is not the case. Because, biomedical engineers are part and parcel of biological science field at every stage. You want to be a biochemist, you can be a biochemist. You want to be a microbiologist after your biomedical engineering, do research in microbiology. Now there is this whole new hype of, biomedical engineers in immunology and pathology, because thanks to COVID, we have a lot of idea of what immunology means. I need a vaccine for a virus in less than 6 months. How is it possible? Without research, this wouldn't have been possible. Your Covishield vaccine or your AstraZeneca Covishield vaccine is the first one to get out in the public. Why? Because they had something called platform technology, where they were already developing or working on vaccines for no particular disease, but they just classified, okay, if there's going to be a virus with a spike protein, this is the kind of vaccine that I will produce. If there is going to be a virus with some lapse in the mRNA, I will produce some kind of vaccine for this. So the researchers were doing a very broad research already. And when the pandemic struck, they knew where to go, they knew what to do. And that is how your vaccine came so quickly. Being in the pharmaco IT field like I am, I know that every drug takes a minimum of 8 to 10 years to get out in the market, because as we saw about thalidomide, every drug needs to be researched, every drug needs to get its approval. There are 3 phases of clinical trials that has to be done. Okay, so in 3 phases, there are different percentage of the population that has to be studied. And when you get into a pandemic situation, the population that you have to study should be of different gender, should be of different race, should be of different genetic material. So there is just so much that you need to do before you go and develop a vaccine. But then researchers, especially biomedical engineering specialists and bioengineers especially, have made sure that give us a pandemic, in 6 months I will have the basic vaccine ready. I can do a clinical trial. And yes, it is all under emergency approval basis. We still don't know if these drugs have any effect or side effects like thalidomide. I hope it doesn't bring in such side effects. But yes, we don't know what's going to happen in the long run. Again, that's it's still a dark future. But are we able to control the spread of disease now with the vaccine? I guess yes. And if you got the vaccine, be proud, because there are some biomedical engineers who have spent all their life in deducing what vaccine or what compound should I use or what gene should I extract to do this. It's not just biotechnology or genetic engineering guys who do it, but I am sure that there are some biomedical engineers involved, at least if not for the right into labs, biomedical engineering research. When the thing goes out into the public, definitely there are biomedical engineers in process. So if anyone thinks I don't know the scope of biomedical engineering, there's absolutely nothing to worry about. Now you know what the scope is. At least when we studied, we didn't know what a pandemic is, be it what vaccine is. We studied it because it was part of curriculum, and we thought, oh, we have to study all this because we need to get marks. I'll tell you guys, there are so many people who didn't get as much marks as they wanted to, but it's been 7 years since we finished college. We can tell you, all of us who have actively been into biomedical engineering has uh, been into some sort of research or the other, or has been into some technological developments or the other, and we are all content that we are biomedical engineers. There are a lot of my friends who are working in hospitals as well, and now they know that their hospital can't function without biomedical engineers, and that every day, just like how a doctor is on call, a biomedical engineer is also on call, because when there is some instrument or something other that doesn't function properly, they need to be there. So that's how important a biomedical engineer is. At least in India, it's a very slow growth. People kind of understand things a little bit later than the rest of the world, but it's still fine. By the time you guys are done with it, I think you would have more scope, and it's not just scope. I would say more job opportunities, because yes, we all want to be employed, and I will come into what are the employment options that you guys have after you become a researcher in biomedical engineering. Okay, so there's just a few statistics I want to put it out to you guys. So so you see these two graphs, like, so one says 10 leading countries in nature index, and if you guys just look at it, um, you don't see our country at all. Where is India? The first thing that I did when I got the slide was Inge India Vakanu. That was my first reaction, because I saw that the United States was somewhere in 2000, 20,000 range, and Australia is around in between some 1,000 to 500 category, and China was slowly catching up. So we know how China is doing a lot of things. Yes, there are a lot of things that we don't like about China, but just look at how that country is going on par with the developed country that has been getting into this research for a very long time. So when I spoke about thalidomide, it was way back in 1960s, and United States had a proper research structure. China was still finding its way out in the world map then. They had a lot of issues within. But now look at the speed at which they're growing. Where are we over here? Yeah, so there are things that we need to think about over here. So the first image is actually about 10 leading countries in natural science research. So it's being produced by this journal called Nature. I think if you um, read in the newspaper, it says Nature gave this data. Nature magazine says something about this study. So Nature is a magazine that has been there since the 1860s, and I think it's been 150 years around in the field of research, and they came up with this statistics, and very sadly we don't find a place over here, but there is hope. If you see in the second image, you would see what is the spending of for biomedical R&D for every country, and you see India's place, even though it's fourth, and we still see China way higher than what we do. But then the research spending has increased. It's around 6.7% of your total economic spending. So economic spending and all might look like something straight out of, if you look at CNN, IBN, Business News, you will hear about economic spending. And Nirmala Sitharaman will be talking every day in the TV about economic spending. But if we don't understand economic spending, we will not understand this graph. So every country has a limit that it spends on the economy. Okay, my government will spend a particular amount. Let's say I'm spending 1,000 rupees for this economy today. My government is saying, okay, if I push in 1,000 rupees, so in this 1,000 rupees, what I mean is I will buy certain equipments for the farm agriculture sector. I will buy certain loan. I will give some loan benefits for the industrial sector. I will give some benefits for the corporate sector. So this is called economic spending, and India has now is now spending 6.7% of its total spending in biomedical R&D space. So if you want to, you have access to newspapers, you have access to YouTube again. Uh, just look at what actual biomedical R&D spending is. But very good news, because our country is now slowly orienting into R&D space and saying, okay, I need biomedical research developments. So I need certain equipments that are very indigenous to my people. We all have a very specific genetic makeup that makes us different from the Sri Lankans, that makes us different from Chinese, that makes us different from the Middle East. So we all have a very specific genetic spending. So there are a lot of things that are very specific to us. In the medical space, there are a lot of diseases that are just endemic to our region. When I mean endemic, it's just restricted to our country alone. So those kind of things can be studied not by some researcher in the US, but then there has to be a researcher in India who would say, okay, this is the kind of research that I want to do on my people. I want to find one solution for my person in my country. So that is where spending improves, because as a researcher, I cannot put 20 lakhs from my bank and say, okay, I will spend this money and find a drug for COVID in India. No, I cannot do. I need that 11,000 crore spending from my government to say, here, I give you the money. You do whatever you want, but then find a solution for COVID. That happens with economic spending. So we can be glad that biomedical research spending is increasing in our country. So if this spending may increase, may decrease, it doesn't lie with us. But if we create a push into the economic space, there are a lot of biomedical engineers who are going to join as researchers in one country or the other. I mean, I'm sorry, not one country or the other. It's when one company or the other, then my country or my government will think, oh, suddenly there is some growth I see in, the Bangalore research space. Suddenly I see some growth in the IIT research space, and they all need funding. Okay, so something good is happening. Because I've been part of this R&D spending between governments and institutions, I can tell you how it works. Every time I work on a project, there has to be some funding that comes in from certain government institutions. So when I was in IIT Madras, the project that I worked was independent, but then I had other future proposals that were coming in from DRDO. So DRDO has this biomedical engineering division called DEBEL. So it's DEBEL if you guys want to look at it. So DEBEL, and there's also ISRO. So there are a lot of institutions like this, and also HAL as well. So you would think, what ISRO is going to do with research in biomedical engineering? I mean, why does it matter to them? They are going to send rockets into space. Why study biomedical engineering? But then you will find that they are very, very curious to find those bright minds, or those minds that are curious to find out, if there is something that they can develop for biomedical space. So for them, the funding comes to the government, and from them it goes to the institution, and then the institution spends that on the researcher, buys you all the materials, gives you the time and the lab for you to do the research. And when it comes out, the government can proudly say that we have developed a drug for you. So that is how it works. And when there are more people doing research, the government will be forced to spend more in this area. And if that has to happen, that we will have to get down and say, okay, I want to do research next, or I have my interest into this. So it's all out in the open for you guys. So if you're interested, post your final year, you can take research up. So we'll come into that again. So you might be wondering, what are the areas of study that I can do in biomedical engineering field? So you have biochemistry, you have developmental biology, human pathology is how we discussed. There's immunology, microbiology, pharmacology, and physiology. So I guess you guys might need some introduction with biochemistry. So biochemistry deals with chemical components. Maybe in your second year, you will have a separate subject for separate paper that you'd have to write an exam for in biochemistry. So it shows about the dynamics and the chemical dynamics inside a cell, and how research can be carried out in biochemistry. So that is one field. The next one is developmental biology. Developmental biology is how one cell becomes another cell. So if you've been following about stem cells, you would know that these are these very most advertised cells you could have ever found in the body. So nobody will talk about epithelial cells in the body, but every other person in every other news, in every other newspaper, they will say stem cell research is doing this, stem cell research is doing this. So there will be so much of news in stem cell. Why? Because stem cells have this characteristic where one cell can become any type of cell. So that is why it's so important in research. So studying about stem cells, and studying about genetic makeup, and how development can happen in every cell. So that comes in developmental biology. Next is human pathology. Human pathology is about patho is pathogen, where is any foreign body that affects your body is a pathogen, and how your body responds to it, what are the antibodies that are created. I'm hoping that you guys would have heard about antibody, antigen, all these things over and over again in the last 1 year or so. So yes, so studying about our body's response to external bodies or foreign bodies, like pathogens or microbes, fungi, virus, all these is human pathology. How your body begins an immune response. So if I get a cold is not a disease but a symptom, and it's also a immune response of your body. So when I sneeze, what happens is that, so let it be something like a pollen allergy. So there's a pollen that gets into my respiratory tract. If I just let it sit there, it would block my alveoli, and there will be no exchange of gases that are taking up, and I would die of pneumonic arrest in a couple of hours. But this body is so brilliantly made that when you inhale pollen, immediately there is a response that says, "Hey, there is a foreign body that has come inside. Push it out." So that's how you sneeze and you push that pollen out. So that is your immune response, and studying about that response is immunology. Next one is microbiology. We saw about these various pathogens that are affecting us. How is the pathogen made up of? How is your cell made up of? Is there any cellular structure that I need to study? Is there any genetic material that I need to identify? All those are classified in microbiology. Next one is pharmacology. Pharmacology is studying about the medicines or the drugs that can be used to treat people, medicines that are used as medicines, and some compounds or drug compounds that are used as uh, you know narcotics or things like that. So study about all that, and more importantly, it's mostly about how to develop a drug out of compound. All that comes under pharmacology. Next one is physiology. Physio is more about the function of the body. So study of the function of the body is physiology. Okay, so these are just a few areas of biomedical science study, especially if you want to go into core science after biomedical engineering. This is the space for you guys to do. Okay. Okay. So this is one question that came into my mind. Wait, what am I going to gain by doing research? I did 4 years of engineering. Why do you want me to do another 3, 4 years of research? What about my life? That is one question that even I asked when I was in IIT Madras 1 year, and I was like, oh no, I can't handle this, because every study that you take to your professor, somehow your professor will come and say, I think there is something that you can change in it. Go to the other lab, check with those people how they're doing it, bring out a study, and let's see how this is happening. For the first time, you will be like, okay, there is something that I'm learning. But then when this happens for the 12th time, 13th time, you will think maybe this woman, my professor, is a mad woman who wants me to walk up and down to labs and make me lose weight. That's the only thought that will come, especially when you're inside on huge campus like IIT Madras, or there are even huger campuses outside. You will think, you will have this this feeling of so much hatred towards your professor that you think, why did I step into doing research? But then let me tell you, those are the years that molds you into research in the future, because not every drug that you develop or every compound that you identify for drug development will become a drug. There will be so many studies that you need to do. There will be so many things that you need to see, that you will have to endure this feeling of not being accepted immediately, because these are the things that build you up for the future. So because my professor made me walk up and down from into many labs and made me do these things for many, many years, I mean, for many years, at least for me, a couple of years, I know how difficult it is to, when someone says this drug isn't working, we're going in for a different compound. Yes, I understand what's going on there. So these are things that structure you for the future. So what am I going to gain? I can do research, I can get a degree, or I would get a PhD. What after that? What do I do? Am I going to gain something by this? Mostly we will think, I don't see a future, because I hope I'm not scaring you guys, because if you take research in the future, you can do you can do a master's, and then you can also do a PhD. And in IIT, it takes an average of 6 years to finish your PhD, because there are a lot of things, a lot of process, a lot of research, a lot of writing to do, a lot of defense meetings that you need to attend, and you need to defend your research as well. So all these takes an average of 6 years. So I have known people who have done their PhDs for 10 years as well. So they will tell you your PhD will be done in 4 years, but any normal average PhD will take a minimum of 5 to 6 years. So, are you prepared for 4 years plus 6 years? So that's around 10 years. Are you prepared for it? Because a lot of times after the third year of your PhD, you will think, I don't think I'm gaining anything. But let me tell you that move on to the next slide. Uh, so you guys are aware of NASA? Again, I would want you guys to unmute and tell me what you know about NASA.
Yeah, ma'am. Yeah, full.
Okay, so all right. So, do you think NASA has any, you know, what I call any relevance to the topic that we're talking today?
Yes, ma'am. Because only biomedical students can find out if there are any biological components present in some other planets, or any biological traces are there.
Mm-hmm.
Something like
Brilliant, brilliant, Anushree. Yeah. So yes, NASA. So 18,000 is the number of biomedical engineers that work with NASA. So NASA has separate 2 or 3 departments that work on identification of biologics. So it's not just about finding out, if there are any biological traits found in extra terrestrial areas, but it's also about how the space explorer that you're sending out into uh, uh, the space or out of your atmosphere will survive. So I need to check his vitals. There are doctors who work for NASA. So apart from them, the biomedical engineers have to, study how long will they survive with oxygen. Can there be any membrane that I can develop that would make them stay even more longer without an oxygen cylinder? So these are the different kinds of research that going in NASA. So they have this thing called the BEAST lab. Okay, so BEAST, I would say what. So BEAST is the Biomedical Engineering for Exploration Space Technology. It's called the BEAST lab. So yes, NASA has this separate category, and you would be amused to find the number of Indians over there. Okay, and Indians, when I mean Indians, you would think, oh, they would have done their masters from the US. No, people from colleges that don't even come up as close as the IITs in India, very simple colleges from India are working in NASA because they push the right buttons. I mean, when they push the right buttons, it means they had strived hard. It's not by anybody's recommendation that anyone can get into NASA, but then by your work, by your purpose, or by the curiosity that you explain to them, that is how you can get your berth in NASA. So it's not just NASA. As I told you, ISRO, DRDO, there are a lot of research institutions within India. There is CSIR. So if you guys, you get time, probably after you get 2 doses of your vaccination, make sure that you just go out and explore certain places in whichever town that you are. If you are in Chennai, if you go to Taramani, you would find this sprawling campus called CSIR. Go there, talk to a few people, I think you can just get permission to go there just by writing out an email to someone. Definitely all the email IDs are provided in the websites. Write out to one researcher over there, tell them, I'm curious to meet your lab, I'm curious to explore what is happening over there, can I come and meet you? They're not going to tell you a no. They will give you an appointment. They will say, okay, come during this time, this day, I'll give you 2 hours to look at the lab. Go there, make an engagement with them. Tell them, okay, sir, if it's possible, can I visit you once in a month, probably this week? Be curious. Learn to work on a lot of things, even when you're not mandated to. No professor of yours is going to come and tell you, I want you to go to this lab, I want you to go to that lab and explore. It is your future. And if you want to explore things in terms of research, please do that out of your own interest, because your professors have enough and more things to worry about. Yes, you need to study. Yes, there are papers that make you eligible for this field, but then your curiosity is what defines how you will end up in the future. Okay, so unless and otherwise you're curious and you reach out, things won't be served on a platter to you. When you get out of college, you will understand that. So yes, so there are 18,000 biomedical engineers in NASA, and this was news to me yesterday when I was preparing for these slides. And I was like, 18,000? Are you kidding me? That was my response to it. But See the scope for you over here in NASA, and imagine NASA is sending people out of space. We need people to survive inside this planet that we have, inside our country. So imagine the number of people that our country needs, number of researchers that this country needs. So now I think you would have more orientation towards research. So, and apart from this, there are also, not NASA just doesn't focus on going out of space, extraterrestrial places, and things like that. But it also does a lot of research on. It's pretty amusing to me yesterday. So when I was looking into it, NASA does a lot of research on molar implants. So you have your teeth. There are molars, your wisdom teeth, and they work on molar implants and how these materials can be made better. Okay, so NASA does that as well. So you would never know what is the research area of this institution from the government, but there are a lot of things happening out there, guys. So you need to explore if you want to know about things. So make use of uh, these channels called, TEDx talks. There are a lot of TEDx talks that you would find. You would find a lot of celebrities on TEDx, but I would say keep them aside for a while. Look at biomedical engineering TEDx talks, and if you're not inspired, please come back to me and tell me why you're not inspired. Because when you go through that, you would know what is out there and what am I doing here. I just look within these four walls and I think, even if I study biomedical engineering, if I get into Infosys, what is my future? You don't know the number of projects that Infosys is working upon in biomedical engineering. So treat every opportunity as a stepping stone, and then from there you can move on. So there are just plentiful resources available for you, right? So make use of all that. So yeah. So the next one is various avenues of research. So we saw about some biomedical sciences. We will see about specific biomedical research areas that are happening right now. So if you see, there are some random images you might think, but the first one is called biomechanics. So biomechanics is how your body is mechanically acting. So when I walk, is it mechanics? Yes. When I run, is it mechanics? Yes. When I do something specifically, is it mechanics? Yes. When I move my knee. So if you study, there is biomechanics paper in your fifth semester where you will, I think for us when we learned, it was about, I just finished with my mathematics classes. Why am I sitting here and studying about the angle of rotation? But you would be so interested if you study a lot of sources, you will know. Please, now you have, again, I keep insisting or emphasizing on this point that please use YouTube to the maximum. There are so many study materials that are available. There are so many videos that are available. If you want to search how my biomechanics of my bones work, please look at it. You will see how your bones turn from one angle to another and how it doesn't break in all these angles. Okay, this is so interesting. So these are all biomechanical research. And when I look at certain cricketers and their actions, and their biomechanics is involved. When I see a footballer like Ronaldo or Messi do something, uh, definitely there is a particular jump that Ronaldo does when he kicks in his goals. You will find how he alone can flip and kick a goal and make sure that the goal hits inside the goal post. That is a biomechanical action that you can study. All these need biomedical engineers. And then you see these this the vertebral column fitted with a lot of screws over here. This is a regeneration of your spine with implants. So this is another study where you have regenerative engineering, it is called. So you can find a lot of implants. Even your dental implants fall under the biomedical engineering category. And then we saw about stem cells. There are a lot of ways that this can be engineered, and these are cell and molecular engineering divisions. So these are other avenues that you can look into as well. And what are these? These are your scans. So again, there are a lot of imaging process that happens within biomedical science. So there are MRI scans, CT scans, X-ray, and all these things. So these involve complex algorithms. So not just biomedical engineer, you also need to transform into a computer science engineer to know how my software works, how can I make this software better. So there are imaging science engineering that happens. So there are a lot of imaging tools. Okay, so when I did my project in final year, it was about specific software called Mimics. I still don't know if it's in the I still don't know if it's still in market, but then there was a software called Mimics that used ANSYS. So I'm throwing in a lot of terms to you guys, not necessary that you need to know, but it's just giving you a context of how many softwares there are for you to getting this imaging source. So all these involve software, and then you are more than a software engineer because you need to know how my brain is structured. If I want to know where my tumor is in this image, I need to know how my tumors can form. Also need to know how I can make this imaging better. Is there any specific mode that I can give so that this image gives me a proper identification, or my proper identification of my tumor? Yes. So for that I need to know my software. I need to know about the brain. I need to know about my scanning machine as well. So that also involves a little bit of your instrumentation, your software analysis, as well as an anatomy. So you are into this multidisciplinary engineering side. So I would say that you are not in core engineering aspect, but this is a multidisciplinary engineering field where you would need to know a little bit of everything. And finally, when you specialize, make sure those little bits add up. Okay, so this is imaging and imaging sciences. So there is also something called as biophotonics. So it's about study of light. So you need the proper lighting source for you to identify these images. So uh, we've all seen an X-ray in our life for sure. So when I want that X-ray to be picturized properly, there's a specific amount of light that needs to be emitted so that my image is coming properly. So those are biophotonics. You're studying your biological your biological system through the use of light. That becomes biophotonics. So anything you put a bio, it's still applicable and it still works out. And then you also need medical devices and engineering, right? So the first image that I see is a medical device. uh, the normal syringe that I see, it is a medical device. I need this medical device, otherwise my vaccine policy is nil. So, do I need specific knowledge in manufacturing the needle? Yes, I do. I need to know the gauge sizes of every needle, so that I need to know my doctor will, or my nurse will find out how to put the injection into me, or the vaccine has to be administered. So there is a certain way that you hold the needle. There's a certain way that you insert it. So all these things, the needle sizes, the needle manufacturing, has to be overseen by a biomedical engineer. Otherwise, you wouldn't know whether my solution that I'm pressing through my syringe, is it going into my patient? Is it going into the muscular system? I wouldn't know if my needle syringe is proper. So I think next time when you get a syringe without piercing yourself, make sure that you find out that you just take it out. Make sure that you carefully study this needle with the needle that you use for sewing, because both these are classified as needles. Just make sure how these things are different. Study it for like just 5 minutes. Just have both these in hand with you. See what is the difference between these two. Then you will understand why you're needed over there. Okay, so it's not just these monitors. So this watch that I'm using now, so this is a wearable device because it can measure the number of steps that I take every day. It can measure my heart rate. It might not be accurate, but still measures. 10 years ago, this was nowhere to be seen. I was thinking of, since I wear specs, I had this, and I think when I was in third year, I had this idea where I thought I have this frequent this thing where I remove my specs and I don't remember where it is. So I was just very casually talking to my professor when I told, Sir, I think we should find out this device to find out where my specs is. He was like, okay, why not think about it? Just come up with something. And then it didn't materialize, but I was into this idea that maybe I should fit my spec with some sensor and attach it somewhere to my mobile phone, so that when I have displaced my specs, I should find out where it is by just an app in my phone. So those were very, very tall tales that I was telling myself. But then I would say that in 2017, I found this newspaper article where one scientist actually worked on it and found out how to trace specs using an app and the Bluetooth device. So that was this wow moment for me, and also a little bit of, and a very sad moment for me, where I thought maybe if I just worked on this idea of mine, I would have, uh, you know, done something with it. So I wouldn't have let that Israeli scientist to find out something like that. So there's very, very dumb ideas that come into your mind. I wouldn't classify it as dumb now. Then I was thinking, how dumb for me? Maybe I should just remember where I kept my specs. So, those things are innovations in the future. So that is one. And yeah, so all these are classified as wearable devices, and they all come under biomedical instrumentation, because now your Apple watches and your Samsung smart watches are becoming more and more accurate. So true. So that was the other day, there was news about where an old man's fall was alerted immediately to 911, because his Apple Watch told that, recognized that he had a fall, and it had immediately sent an SOS to 911. So 911 to get alerted. So there had to be a biomedical engineer who had to know biomechanics and say, the person was standing, now the person is immediately in flight of time, he is on the floor, so he has had a fall, and this watch has to identify that there is a fall that has happened. So if you just, it just blows my mind out when I think of such things. And uh, those are the avenues that you can explore in the future. You have a lot of opportunities now, and even I had a lot of opportunities when I was studying, but I will tell you about my utilization in a few minutes. So yeah, so another category that you can study is about neural networks. So neural networks are about studying the mapping of your nerves in your brain. So brain is the most complex organ in your mind, which has still not been deciphered. Someone tried building an artificial supercomputer with how a brain was designed, and they the maximum they could get was try to make these computers uh, get a reflex action. And I tell you that the entire network of that computer spread across 3 buildings in a research firm. So imagine how complex your brain is designed. So I believe that every design needs a designer, every art needs an artist, and every creation needs a creator. And I would say, if not for the creator, if not for this creator who had developed you into who you are, I don't believe in evolution, guys, because there are still monkeys alive. Can monkeys become us? I don't think so. I don't know. You might have different views, but this is my opinion. For a human being to have such complex mechanisms inside your 6 feet tall organism is out of this world. You can even design a huge machine, but it can never come anything close to your brain. Wow, that is creation. It needs a creator, because every time I studied anatomy and physiology, it make me go wow, because even 4 or 5 books are needed for anatomy and physiology. We learn something that is very on top of things, but imagine the exploration that you can do over this in terms of research. So yes, guys, so that is one. So neural networks in healthcare, you can study about this in research as well. And then you would have this question about, okay, so why should I start my research? Should it be in IIT? Should it be in IISc? Or should I go somewhere else to other foreign countries, do my master's? Where should I start my research? And I think your research should start here, your newspapers. So if you have any newspaper at hand, I am sure that all these newspapers have a section dedicated to science and technology. And at least every other week, you will find one person or the other, or one institution or the other, that has come up with some breakthrough research in biomedical engineering. So are there people who read newspapers here, or is it just very few? Anybody who reads newspapers? It's very quiet. Okay, so if you don't read newspapers, make sure that you subscribe to at least any of these dailies, and stay on top of things, guys. You needn't have to read editorials every day unless and otherwise you want to become a UPSC aspirant, become an IAS officer. Please go ahead, read all those editorials. But if you love to read, if you're reading any other random author, uh, some books, some story books, if you're reading Will Vigadan also, make sure you park that aside. I wouldn't say don't read those books at all. If you want to read the newspaper, skim through it, spend 10 minutes per day and see. Because I have the newspaper from yesterday that says, from Hindu, which says science and technology. So you have it here, you have it every Sunday. You have this coming up every Sunday. So can you do something better? Yes, you can. So make sure you subscribe to one newspaper at least every Sundays, and go through these pages and see what you can do, what you can explore in the future. So apart from that, if I want to study a little bit more about biomedical research, I can also go into these journals. So these journals will be available in your college library. Because we haven't looked enough, we wouldn't have got any of these. I'm sure every college has a library that subscribes to at least a few journals or the other. And if these journals aren't available, specifically biomedical journals aren't available, I would say subscribe to some of these online. You have Scientific American, there are a few things that are online. Spend a little bit of money and try getting some of these. And this is one place where you can do your research again. So the next place, sorry guys, I'm just working from home, so I haven't spoken this much in a long time. Sorry for the interruption.
Ma'am, you can drink water and continue. Is it okay?
That's fine, ma'am. I think I will just go ahead. Yeah.
Okay.
Right. So this is one place where I did my research is IIT Madras, and next one is Indian Institute of Science. So this is the Indian Institute of Science. So apart from studying here, the biggest opportunity that you get is the campus itself. Try visiting IIT Madras if you're in Chennai sometime soon, or I think by the time you guys come to final year, this pandemic would have been averted and so many things would have happened by then. Try visiting there at least once. Just the campus is enough to make you feel, wow. The buildings are old, I tell you, but at least go to these coffee centers over there, and you would hear the conversation of people who talk. They are not the usual stud people that you see, that you imagine them to be. They're a lot of fun, and there are a lot of public avenues, like there is Shastra that happens, there is Sarang that happens in IIT. So get involved. This is for IIT Madras. There are a lot of IITs. There are around 26 IITs in India now. Not just IITs. There are even Anna University campus is really huge. There are a lot of things going on, and you would find all these to be interesting. Yeah, and then when you're done with your Indian research, if you think you want to explore further outside of countries, maybe just try researching about Johns Hopkins University. It's touted to be the best in the world. And the US is a very expensive place. So my personal suggestion is go to Europe, because your tuition fees is zero. You will just have to spend about some 10 lakhs probably for 2 years for your stay in Europe, and that 10 lakhs you can gain it back like in a year or two after you join for work. So another avenue that you can look at. So it's not just US universities. Go in for TUM, Munich, Germany, and then there are a lot of TUs all across Europe. So these are all the avenues that are open for you guys. Things are changing fast. You need to keep up with the world. So make sure you explore your options. Even if your first year, don't think I'm just in the first year, I have time. No, have a plan. So a plan as in you can only do limited planning because you do not know where life takes you. But make sure that you're aware of what and how things are happening around you, and that would give you a lot of insight. Because I wanted to study in Germany, I did a lot of research, but somehow I didn't end up going to Germany because of certain constraints that I had. And I also, yeah, I that's when without Germany, I was like, okay, somewhere I need to get and do some research, and that's how I got into IIT Madras. And then after a year and a half, I thought, okay, I think research is not for me because research needs a lot of commitment, and I don't know, I just couldn't utilize that commitment, or I would say that I was a little too exhausted too early. Maybe if I had strived a little bit more. Um, I would have probably continued research, but I'm very glad that the work that I'm doing involves research as well. So some benefit is there. So some research sometime will definitely benefit you. But guys, make sure that even for research, you would need a good CGPA. So in good, I don't mean you have to get 9 plus CGPAs or 8.5 CGPAs. So inside India, every university requires a minimum of 7.5. So, and that 7.5 is normalized to every institution. So let's say 7.5 in IIT is not equal to 7.5 in Anna University. So both these are different. So make sure that you keep your levels up. So 8.5, if you can continuously get, if you have a couple of arrears, which I would suggest, please don't have arrears in your career, because it affects a lot of time. It affects a lot of, your self thing itself. It might be very cool when you're in college. You say, I have 4 arrears, I have 8 arrears. I had one person in class who had 36 arrears, which was very, very bad. But then it might be cool in college, but when you come out, you would learn that everybody else has passed on and you are still in one same position. So make sure that you don't get probably one is fine. Two is still acceptable, but more than that, people will make sure that they will be a little hesitant of you. So try your level best not to have any arrears. Make sure that your CGPAs are on par. And if you're into research, make sure that things happen better, you know. So I'm not saying that anybody who has arrears will not do good in life, because the person with 36 arrears is now a manager in a firm. So things change according to people's capabilities, and capabilities are not measured by marks, but for research you need to have some academic orientation, and unfortunately academic orientation is not measured by anything else but only through your CGPA. So make sure that you make that mark, just up your game a little bit, a notch above. And so you will be thinking, I have done all this research, so should I end up as a professor? Should I end up as an assistant professor? Should I keep doing research for the entire life for some educational institution? No. There are a lot of companies that hire researchers, that need researchers, that in Germany, if you for insight, but just because I told you about TUM, so we have certain customers who are working in the technical field, and you know what? Almost everybody in that office is a PhD holder. So in Germany, it's very casual to find so many PhD holders walking around. For them, it's like the BE degree. Okay, for us, PhD is something great, but in Germany, almost everyone has a PhD. So any company that hires there would look in for a master's or a PhD, and they are very glad if you have a research background. So, PhD is tough, but if you can finish your PhD by the time you're 27. After that, I would certainly guarantee you that the quality of life that you live is much, much better. So you see all these companies. So there may not be a lot of companies that you would know. There's Roche. Roche is the one that gives you AccuCheck, that the medicine, the instrument that you use for measuring your blood sugars from Roche. Then there is GSK. Your Horlicks is from GSK. Siemens Healthcare. Siemens Healthcare is where your CT machines come in. And then there is Toshiba. We all know Toshiba is companies that give you uh, laptops, but Toshiba has the best MRIs in the world. So you look at all these companies. There are certain companies that you wouldn't even have heard of, but then these are all the market players for biomedical engineers, and you wouldn't have known it. So when I was studying biomedical engineering, I finished my biomedical engineering. There was one uncle who came up to me and he told, "What did you study?" And I was like, "I did my biomedical engineering." And he told, "Biomedical engineering? Did you know that you won't get any jobs after studying it?" I will tell you, that was the most embarrassing moment in my entire life, and I really felt, what do you know about biomedical engineering that you come and tell me that I don't have a job in this? But that is a past incident. But I'm sure that that uncle who asked me that question never knew about all such opportunities. So now you're in the first year, know that these are the companies that can hire you, that will know that, okay, so there are a lot of biomedical engineers available. They also need biomedical engineers. We are biomedical engineers who need jobs. So approach them with the right accreditations that you have, so it will help you. And then again, I'm not yet done. So look at this. There is Regeneron, there is BMS. BMS is Bristol Myers Squibb. There is Pfizer. You have heard about Pfizer a lot. And then there is Abbott. So the next time you guys get a drug, no, when you get some medicine at home, just make sure you flip that thing. See the thing behind the stamp or the seal behind, and you would see that the company that the medicine is produced from, you will find that there are so many pharma companies, and all these pharma companies need biomedical engineers as well. They need to study about drug discovery. There is all of drug relationships with the body that has to be studied. So definitely these are places where you will get your placements. And I wouldn't say so Pfizer wouldn't come to SRM and say, "I need so and so people." If it does, great, but they wouldn't do that, because they need people who can approach them, because they have so many people coming in. So apart from your placements, it's better that after you do your masters or if you do your PhD, make sure that you reach out to them, submit them your resume, and tell them that you're ready for employment. They will be glad to employ you after a certain interviews and things. So guys, there's no easy way out there. It's all there, but you need to reach out. Again, I'm not done with the companies that need people for biomedical engineering. All these are companies that require biomedical engineers. Make sure that you find your way through, and you get placed in such companies. I think I would have spoken about this. I like research, but it takes too time. Definitely, it's not just research. Sometimes you can do your master's, maybe an MS. It's relatively lower. I don't have to do a PhD, do a 3-year course. But then if you say, I don't even have time for master's, or maybe I do not have enough finances with me to do my master's, there are still a lot of certification courses available out there. Take it, do that. Okay. And then to come into the informatics part of my speech, I'm just going to take another 5 minutes. Is it okay, Lalita ma'am?
Yes, ma'am. Yes, ma'am. You can go ahead. Yes, ma'am.
Yes,
Okay.
ma'am. Yes, ma'am.
Thank you. Yeah. So the next one is about for people who are wondering about where does IT come into all this. So when I was in college again, um, there was this big hatred towards IT, that whenever there was computer labs, you'll think, please, I don't want to get into computer labs. I don't want to study that C++ and that Linux programming and everything. But guys, I don't know if it's a myth or something, but IT is interesting when you know that the code that you write can do something. It's not about always 1 plus 1 2. That's a basic code that you can get. Go into the again, there are so much of YouTube channels that give you so much information now. There is AngularJS, there's Python, there's so much of codes and software that the biomedical engineers use. So as I told you, your MRI scans, your CT scans, all these need codes and softwares. So you need to know programming. You need to know some digital signal processing for that. And there is where your IT comes into play. You need a little bit of IT everywhere because we can be all the more say I don't like computers, I don't want to use computers, but computers, what is getting us connected today? If not for Zoom, I don't think we would have met today, right? So you need computers. So computers have become such an essential part of our lives that we cannot do anything without it. Again, if my wearable device like this needs to work, it needs codes, it needs software. So all these are, when you get that IT plus biomedical engineer, you're the MVP, the most valuable person in that area. So try learning a few programs and codes. It will help you in the long run. And when I mention the long run, I can talk to you about this person. I don't know if you guys remember the 2012 Olympics. That is when we were in college. So I'm not very sure if you guys know about 2012 Olympics. So there was this person who, as you see, he was called as a Blade Runner, mostly because of the prosthetics in his legs. So he had no legs, but still he competed with other runners in Olympics. Imagine running next to people like Usain Bolt, and you don't have legs. Usain Bolt has such long legs, but he doesn't have legs. So this is Oscar Pistorius. Go learn about him. Now he's pretty infamous because of certain incidents that doesn't let him run in Olympics anymore. But then when he ran with this was the biggest leap in the biomedical community, because you see these prosthetics, if not for some code that reads from his movements, if not there's some biomechanics involved here, he wouldn't have run. He couldn't be balancing his entire body weight on these two flimsy prosthetics. So the materials, so you need the materials, you need that implant that reads his running, you need sensors. So if not for biomedical engineers over here, he wouldn't have run that Olympics and he wouldn't be called as the Blade Runner. Okay, so our focus is more on his legs. Read about him, read about Oscar Pistorius, you would know that. So come into this place where nothing can happen without computers. So before you say, I hate computers, pause, think for a moment. You need them. As biomedical engineers, if you know them, you're one step above a lot of people. Okay. Again, I would like to bring your attention to this image over here. So you see a lot of cameras, you see a stump, and you see that there is something over there. So, for people who follow cricket, you would know that Muthaiya Muralidharan and Harbhajan Singh fall under a special category of bowlers. Why special category is because when they come bowling, when you see India versus Sri Lanka, if you had seen India versus Sri Lanka, you would see that both these bowlers are very different from your normal Ravichandran Ashwin bowling. Right, so people who know watch cricket, you would understand, because Muthaiya Muralidharan literally gives you a scare when he comes and throws that ball. His bowling action is very, very scary, and the way he bowls, some people were telling it's not even proper bowling. It's something different. I wouldn't consider this to be bowling. And Harbhajan Singh, you would have seen how Harbhajan Singh very happily comes and bowls. Like looking at him looks like as if he's doing this the Gabra, and then he's coming in. Doing the bowling action. So these two players are two people who I can remember who are come under the category of suspect bowling action. So the way that they bowl is very different. So ICC, the ICC is the Governing Council of Cricket. They told we need to look at your bowling action, if it is proper, if it is not proper. So the facility that you see is a world-class facility, and this is not England or South Africa or Australia where you're looking at. You're looking at Sri Ramchandra Medical College right there in Porur. It has this facility that checks for the biomechanical action of bowlers. Okay, so if you get an opportunity again, so all these places are very close. So Ramapuram is where your college is. I was living near Ramapuram over there. So I know your college very well. So just spend 15 minutes, go to Ramchandra, ask them for where this place is, get a permission, look into it. So all these camera gets a capture, an image of this bowler when he's doing one point one other. All these are monitored through huge monitors and then they are studied. Biomechanical experts sit there and study how the action is. Is it crossing the line? Is his elbow in the right place? Is his knee placed in the right place? All these are biomechanical experts, and obviously they come from the biomedical background. So again, another scope for biomedical research. Okay. I'm sorry. The next one is you see this researcher, she's doing some research, and there's this huge screen out there. So for this huge screen out there, you'd see that these are your genetic material. Your double-stranded helix, your DNA is seen over here, and she's also seeing a lot of blood cells over here, and she's run certain bands that you see. So these are all electrophoresis bands. So all these are machinery that is involved in a lab. But then for this machinery to be inside your system, you need a software. There are softwares that do it. So again, IT in BME, this is it. So these are the softwares. So when you talk to these experts, these scientists, so that's something that I've been doing for the last 4 to 5 years. So when I talk to scientists, the one thing that they want you to do is understand what they're talking. As a computer science engineer, if I go and say this program given in the code there is one error and that code has to be a little bit modified, they will not understand. You will have to gather the requirements from them in such a way that what they're talking is understandable to you. And that is where biomedical engineers are required, because you know what to do in software, you also know what is their requirement. Have this thing called the domain knowledge of the science that you're working in. If it's about a company that manufactures prosthetics and needs, you will have to know how my biomechanics is structured. You will have to know the angle of rotation of your ankles and your knees, and you will also have to know a lot of the muscles and your nervous actions and things like that. So if you know a little bit, if you know your domain knowledge and you know your IT knowledge, the scientist is going to be the most happiest person, because they're very glad that whatever they're talking makes sense. Otherwise, for them to come up from a very biomechanical or let's say a biochemical background alone, because when you go for such jobs, your scientists are mostly based out of Europe and the US. So there they have a lot of diversity in the topics that they study. So they are very, very specific people. They don't read everything under the sun like us. But then as biomedical engineers, again, we can go and talk about things that make relevance for them as well as for us. So again, there's another scope for IT and BME. So the next one is, your sample collection. So now the latest in thing is automated labs. You don't have people to do pipetting and running it on technology anymore. You have robotic arms that are doing it. So this is the future. We are working with scientists like that, and that next time when I work with someone, that scientist could be someone of you. So 10 years down the line, if I can see a few people over here working on automated labs, I think that will be the most happiest part that happens. And you see this man over here, he's getting his COVID swab done, an automatic machine in the UK. So this is also come up. So you think any random engineer can do it? No, you would need your BME as well as IT. So I think enough stress on this. So these are a few quotes that happen. These are few parts of technology where lab manufacturing comes in. So there are things called electronic lab notebooks. There are things called as lab informatics management system. That are also called as scientific data management systems. So these are all IT terms, but then these are not exactly IT, but these are the technologies that are used inside the labs. So try exploring some of these options in Google. Just probably search for these and you would know. So ELN, what it does is, as a scientist, you would have seen us even in college. What we do is we write all our observation and record notebooks. We have our records where we write, okay, this is my sample quantity, this is my result, and things like that. scientists have to do it. But then because when they're working in all these pharma labs, they'll have this huge record registry where they have to enter data day in and day out. Imagine doing the day in and day out. Writing record notebooks itself will feel like such a pain in our hands. We'll be like, I can't write anymore. But imagine being this lab professional, working on samples and also writing these notes is very tedious for them. So there are systems that are in place where the user has very, very minimal data entry. They'll just have to write the amount of sample that they enter, right? What is the process that is going on? All these calculations are automated by IT professionals or people who develop the software. And again, the software professional will have to talk to the scientist and then get to know how I can make the domain and the IT play in the same thing. And then these results, as soon as they are entered, the data is entered, very, very minimal data entry. I will have some 10-15 pages where my results are automatically calculated. It gives out graph, it gives out things called fit charts. And so many data visualization that happens from all these things. So try exploring these. I think they should help you. And yeah, the next scene is if you guys are Marvel fans, if you have seen Black Panther, you would know who this is and you would know what happens in Wakanda. So in Wakanda, they have these extremely brilliant technology of the future where everything and anything is made and everything can be done. It's by if you guys haven't watched the movie, please go watch Black Panther. Watch Marvel. It's interesting because a lot of future technology that is involved, it can make you very curious. So here you see, over here you see that this is something very similar. So it is backbone that she's replacing, and she's seeing a lot of text on the screen, and she sees, okay, what is it that is damaged over here, how she can replace and things like that. This might take another 100 years or maybe another 50 years to come up like that, but I guarantee you those days, whatever was seen in James Bond movie is becoming a reality now. In 70s, whatever was thought as science fiction is a reality now, 50 years down the line. So I'm definitely sure that Black Panther came quite recently. I think in another 25 to 30 years, this might be a reality. And for this to be a reality, they need researchers like you and me in the field. Okay, so one question that I put to all of you is, are you future ready? The future is out there, but are you ready? I can be in my own bubble and say things are like this. I think this is the scope that I have. This is the future that I have. I don't know what I can do anymore in the future, but you need to be future ready. Otherwise, the world is going to go forward and we're going to be stagnant, and that is not going to help us. So please explore your options. Please think about it, and I'm sure that the future will be better with you guys as biomedical engineers on board. If it can be better with people like us, definitely you have more exposure, more knowledge than what we studied. So you need to be future ready, guys. So any questions for any one of you? Anything that has increased your curiosity today? I would be happy to take questions if you have any. Or if you think this has been very exhausting, one of us, so this crazy woman going on and on and on, please feel free to share that as well. I wouldn't mind.
Ma'am, I have one simple query.
Yeah. Yes, ma'am.
What is the procedure as undergraduate students to enter into research in IIT?
Okay, so how I entered into IIT was that again I showed you the newspaper, no ma'am. So when I was in college, I remember being a third year student. I saw this very small advertisement that told summer internships for bachelor students. So IITs as such advertise only through two ways. One is through newspapers and one is through their websites. So as a summer intern, you can get in. So in the third year, when you're done with, I think during the transition from third year to fourth year, even now there are there is this paid internship that IIT provides. So for that, you will just have to apply online and give a small write-up about the area of research, and then join in for summer internships. Uh, and then from summer internship, it goes on for 2 months. So you will have a very good relationship with the professor over there. You would get to know them more. You will get to know what is the lab, and you will also be in touch with a lot of other professors. So if you're going through that route like me, who did a project associateship or a project internship right immediately after my undergrad studies, you can just go in through connections, go in for a formal interview for that summer internship, and from there, if you keep visiting them regularly, talking to them, or just applying to them online, writing up a mail to them, they would be happy to have you over there. So that is for project associateship. If you want to do masters, you would need to write GATE. And again, MS goes through this project internship.
Okay, ma'am. Okay, ma'am. Thank you so much, ma'am. Any queries, students?
Okay. Nobody has any queries, I guess. I think,
Yes.
yeah, feel free to reach out to me anytime. You can contact Tushis ma'am as well, and let me know what you guys want to know. Be it research or anything. So IITs are one way. If you want to do a PhD again, so all these are available online, ma'am. So if you go into the IIT website, I go into IIT Madras website, for every department, they will give an advertisement saying we need people for this and all. So for PhD, if you're done masters, I think just getting in through the professor, you can go in for PhD. But then GATE is that thing that gives you an entrance into all these things for masters. So PhD is more like you'll have 2 rounds of interview, and that's how you get into a professor who can be your guide for the next few years. So it's all about reaching out and your contacts with people.
Thank you, ma'am. Thank you so much, ma'am. Next, vote of thanks. First, I'd like to thank our management, Dean Sir and HOD Sir for allowing us to conduct these kind of webinars for the benefit of the students. Next, I extend my sincere thanks to Ms. Richa Matthew for spending her valuable time in educating various research aspects of biomedical engineering. Next, I extend my thanks to the coordinators and participants for spending their valuable time in gaining the knowledge. Thank you, one and all. Thank you so much, ma'am.
Thank you, ma'am.
Thank you, ma'am. Thank you, guys. Hope you guys have a very good future ahead.
Thank
Okay.
Thank you.